Yeah.
You can access now? Okay. You're Kevin, right? Okay, everybody. Good morning. Well, no, it's good afternoon. And you're Haley, right? Hal. Yeah. Okay. All right. And happy Monday to you all. And let's get started. I just want to do a little bit of recap from last lecture and move into nutrition label just after that. So let's try to remember some examples tests we would do in case of a product development. So if you think of the example I gave last time, changing butter to vegetable fat. Do you remember any of the analysis we would need to do? I know it's Monday, but you guys can do it. Changing from butter, which is animal fat, to vegetable fat. What would you test for? Yes, Gavin?
Sensory test.
We can do sensory test, of course, Medora.
Shelf life.
Shelf life, because you change the fat from saturated to polyunsaturated, it would be more prone to oxidation. We talked about physical testing as well, rheological testing, of course, the safety, as well as the shelf life. All right, so if you're competing, what would you do? If you want to produce a product similar to another, yes, how?
How you're
Oh, how?
you're good. Reverse engineering.
Yes, you start by reversing engineering your product. Some of you today from Monday groups did some of that. You want to understand a little bit about the formulation. You want to bring the competitor product and maybe produce one and compare sensory evaluation. So you start somewhere like that. If you have a change in process, so the example that we gave last time is you are processing soy flour and then we changed the cooker. And then what do we want to look for a fermentation type of use? Go ahead, just Carol.
You need to do the liquid test, so making sure that the pH is so fine.
Yes, pH, moisture, but one important thing, if you it's going to be digested by microbes, and soy flour is high in what nutrient here? Protein. So what do we want to make sure the protein is not denatured? Okay. Food forensics. Somebody, you are an ingredient company and somebody came to you and said, we have sharp object. What would you do to identify the sharp object? If it's glass, if it's something else? If it's metal, if it is, what would you do? Just something physical. Go ahead, Braden.
You can verify your metal detectors, or you can use microscopy to make them non-metal.
Absolutely. First of all, if you think it's metal, you run it through metal detector. If it's not metal, it looks like glass. We look at the microscope, and actually in that particular case, it was crystallized sugar. So think of examples like that. if it comes in a quiz or an exam, so you're able to answer. So it's something that helps you study. Okay, so this is just a quick recap of that intro, and then I'm going to move into nutrition labeling. So this topic is basically introducing how a nutrition label is formed, what's the content of nutrition label, how you generate the nutrition label, you do that in lab. So, and the origin and the history of nutrition labeling. Okay, good. So FDA, what does it stand for, the abbreviation? Lisa. Great. Do you remember what FSIS stands for if you've taken food quality? Anybody? Yes, thank you. Priyanshi. Food safety and inspection services. Okay, so according to these two agencies, and these two agencies regulates nutrition labeling. According to these two federal agencies, nutrition labeling regulation, the following is true. Okay, nutrition labeling is required only if the food contained an added nutrient. Nutrition labeling is required only if a nutrition claim is made. Showing percent daily value for protein is mandatory. That means it's needed. Methods of analysis are to be determined by the manufacturer, or stating percent daily value for vitamin A and vitamin B12 is mandatory or required. Okay. What do you think? I don't expect you to know, but guess. Cam?
I think D.
You think D. Okay, let's take another answer. Hold the thought. Okay, Carol. A. Okay, let's see what other answers hold that thought. Ash? A. All right, you're solidifying A. Great. Jason? You think E? Okay. It's getting interesting. Any other answer, Priyanshi? D. D. Okay. So far we have A, D, E. Somebody else said C. Nobody said C. Okay. Anybody for B? There's somebody hiding in the room. Refresh. What do you think? Refresh? It's none of the above. Did you say that when I put all of the above, or I tricked you, especially you?
Maybe if you are given none of the above.
No, that's a trick. Okay, so it's none of the above. None of this is correct. Nutrition labeling is required only if food contained an added nutrient. That's back in 1973 Act. Nutrition label is required only if a nutrition claim is made. That's also back in 1973. Showing percent daily value for protein is mandatory only if you're making a protein claim, if it's for athletes, if it's for children under 4. Methods of analysis are to be determined by the manufacturer. It's determined by the FDA and FSIS. They dictate official methods of analysis that are needed to develop the nutrition labeling. Stating daily value of vitamin A and vitamin B12 is mandatory. No, it used to be only vitamin A and C, and now it's neither vitamin A nor C nor B12. It's vitamin D now. Okay, so none of this is true, and we will learn all of this as we go. Okay. So again, here I'm identifying the two federal agencies, the FDA and the FSIS, and they regulate nutritional labeling. So FDA regulates all food except meat, poultry, and egg, which are regulated by FSIS. Early on, the first couple of acts by the FDA and the FD&C, Food, Drug, and Cosmetic, Act from back in the early 20th century. So you just put the amount of food in the package, the common name, what is it? Cheese, yogurt, what is it? Bread, ingredients. So the list of ingredients, that's what was required to be on the label. Now, in 1973, there was Additional Regulation Act, and we'll talk about it, where the nutrition labeling expanded, but it was optional. And then in 1990, the Nutrition Labeling and Education Act mandated nutrition labeling for most of the products. And then we went from just this information over the years to include nutrient content and nutritional value. Okay, so in 1973, the background, it was optional unless you added a nutrient like you fortified with vitamins or minerals. You were putting a nutrition claim, high in fiber, high in protein, for example, so you have to include the nutrition label. So at that time, the role of calories and macronutrients were important. So at that time, they cared for the total calories, they cared for total fat, for the protein, not so much for the micro nutrients. But over the years, there were more focus on vitamins and minerals, for example, on specific components of the fat, like saturated fat and cholesterol, like sodium, for example, vitamin A, vitamin C, calcium, iron. So we moved into looking at more micronutrients, and it became mandatory for almost all food. I say almost all food, but when you go to groceries, which foods you don't see nutrition labeling on? Ash?
Produce is good.
Produce?
Fresh.
Huh?
Fresh.
Fresh food, like produce, vegetables, fruits. Yes, what else? Go ahead.
Raw meats.
Yes, and for example, eggs, eggs in shells. Something else you don't see in nutrition label, if you get a big container pack and inside of it there are little packages like M&Ms. Sometimes you get a whole bag and inside of it there are little M&Ms pouches. So on these little ones you don't see nutrition label, you see on the outer package. So another addition in 2003 was the trans fat. So in the 1990 Act, there was no trans fat requirement. There was an amendment in 2003 to include the trans fat, given the knowledge that the trans fat had as adverse effect on health, especially heart diseases. So the nutrition label right now changed. This was the original one, and then they proposed the new one in 2014. It got approved in 2016, and it got delayed to be enacted or enforced. The compliance date was early this year. So now you look at this and here, what do you notice most obvious change?
The calories is now bold.
Yes, look how much calorie you are taking. Bold, big. Yeah.
The serving size is also important.
Yes, so they bolded the serving size, so you pay attention to that. What else? Let's see here. Let's go with English. Added sugar. Yes, added sugar. So you still have total carbohydrate. You still have the 12 grams of sugar, but of this 12 grams, 10 are added. Okay. Go ahead, Priyashi. Vitamin D. Vitamin D, yes. So if you see originally it was vitamin A and C. Why is that? Because a couple of decades ago, 30, 40 years ago, we had a lot of people with deficiencies in vitamin A and vitamin C. But nowadays, this is rare. We see more deficiency with vitamin D. We don't see the sun apparently enough. We don't generate enough vitamin D. So a lot of the population, 50% of population have vitamin D deficiency. So this became an important thing. There is one more. Yeah.
There's no longer calories from fat.
Oh, there's no longer calories. I think it's good. Yes, there's no longer calories from that. There's one more important thing.
Potassium.
The potassium. So we still have calcium, we still have iron. Potassium was added due to the knowledge of the importance of potassium for muscle movement and especially the heart. Okay. All right, so we have two terms that you will hear often and you will see on the label. Daily reference value. So you're going to see for most nutrients, you see percent daily reference value. So that means out of the daily value requirement for reference, this particular product with this particular serving is giving you a certain percentage of the daily value or daily reference value. So let's say you need 28 grams and you're getting 14 grams in a serving of a particular food, then you say, I'm getting 50% of my daily reference value. So you look at the daily reference value and then you know how much you're getting from a particular nutrient. Okay, so you need to learn this by heart. It's going to be on the exam. I'm lying. No, I'm asked to memorize numbers. Okay, but this is for your information so that you understand better what it means percent daily reference value. Okay, so for vitamins and minerals, it's called the reference daily intake, RDI. That's what it is referred to. And you'll see listed all of the vitamins and minerals that are essential for our body. And you'll see the daily or the reference daily intake for each of those. And again, so that you would understand what is needed. So for one of the labs, which is atomic absorption, you're going to measure iron and you're going to measure calcium in different products. And we will give you the sheet to determine out of the required or reference daily intake, how much per serving is your product having in iron, for example, or in calcium. Again, you don't need to know this by heart. Okay, so this is also for your information. For also, I would like you to know that there are rounding rules. So when you measure amount of fat or calories or what have you, you don't see decimal points. And sometimes you don't see singular, like you don't see 21 calories, for example, on the package. So anything less than 5 calories is expressed as 0. Anything less than or equal to 50 calories is expressed to the nearest 5. Everything greater than 50 calories is expressed to 10 calories. So there are rounding rules and there are rounding rules for everything else. This would have been important, Sash.
Are you allowed to go like more significant than those? Like if I wanted to put out a product that's like, hey, it's a 7 calorie, bottle of soda or something like that.
So 7 calorie, we just
So
say
like,
5 calories. You don't
that thing that you would express it to the nearest 5, but you said, like, can you be more specific? Or
I don't think I haven't seen anything with 7 or 8. Yes, Kevin?
I was feeling the issue you would run into though is if you got checked, you weren't at 7, if you were like above 7 or something like that. So if you're trying to be more specific, the government might be more stringent on you in accounting for mislabeling. Because they assume a grace period if you follow their rounding rules. That makes sense. I feel like you just get, yeah.
Right. Thank you, Kevin. I made you as teaching assistant. Yeah, that's a reasonable answer. So I just was gonna say, I never seen a package that does not follow these particular rules, but that's a great explanation as to why. Okay. For calories, oftentimes you just count the calories per gram of a particular calorie dense nutrient. Or you can physically measure the calories by a calorie bomb. So basically you put the food, certain amount of food, you burn it off and measure the energy generated from burning off that food. But oftentimes you would just look at the gram of proteins and convert that to calories. How many calories per gram of protein? Anybody knows? If you take nutrition, 4. What carbohydrates? 4. How about fat? 9. Very good. How about alcohol? Yay, you know your alcohol very well. All of you said 7. Okay. So for carbohydrates, sometimes if you have a high amount of dietary fiber, you just subtract dietary fiber because we don't digest dietary fiber. And one note is when you write calories in capital C, that is equivalent to kilocalories. So 1 calorie, capital C, is 1,000 calories. For daily value percentage for protein, we're going to cover that in the protein characterization chapter, but quickly here we use specific tests to determine the daily value, percent daily value of protein. Why I say that? Because sometimes you say I have 10 grams of protein, 10 grams out of 50 grams requirement of protein per day, I'm getting 20% of my daily value. Is this correct for every protein type? If the label says 10 grams of protein, does it automatically mean per serving I'm getting 20% protein, 20% daily value protein? Why not, Ash?
Not all protein can be accessed by the body.
Yes, not all protein can be 100% digestible, that's one, and not all proteins have all of the required amounts of our essential amino acids. So basically, we cannot say that 10 grams of proteins are going to give me 20% daily value unless I know that it is milk protein or egg protein or meat protein. I know I'm going to get because it has 100% digestibility and they are complete proteins. So some of plant proteins are deficient. Wheat is deficient in lysine. 10 grams of wheat protein is not going to give you 20% of protein value. So we're going to learn how to calculate or determine the nutritional quality of protein. In that other chapter, we look at protein efficiency ratio, which is basically based on weight gain, and they use baby rats to measure weight gain per amount of protein consumed, and that's why it's only for babies, infant babies. We don't do it for adults because, you know, thankfully we don't gain weight every time we eat protein. So, and then the other one that is used for children and adults is called the protein digestibility corrected amino acid score. So it's based on the digestion of the protein, also animal model, and measuring the amount of nitrogen in the feces to determine how much nitrogen is absorbed from the amount of protein consumed. And we look at the amino acid score, not only the digestion of the protein, but also all the essential amino acids present. So this, the PD class takes into account the digestibility and the presence of essential amino acids. We'll learn more about that in the protein characterization chapter. So, knowing that about the protein, When do we need to see percent daily value for protein on the label? Dan,
B and D.
did you say A, B, and D?
B and D only.
B and D only?
I want H.
Carol wants to include C, and that is correct. So athletes are looking for proteins, especially bodybuilders, and also athletes that do exercise that waste some of their muscle to regenerate their muscle. They would want to consume foods with specific amount of proteins that are biologically available. So B, C, and D. We don't care about, it's not something we care about when it comes to protein. Calories are, with reduced calorie, you mostly is associated with reduced fat content. Okay, so these are recap questions. I'll ask them later. Okay, compliance. So like I said, nutrition labeling is regulated by the government, by government agencies. So companies need to have compliance with the regulation. So there are several compliances. First of all, sample collection. So in chapter 5, we're going to learn about sampling and sample preparation. For nutrition labeling, there are specific ways to sample and number of samples you take out for the analysis. So we're going to learn about that later. Methods of analysis, they have to be official methods of analysis. FDA wants us to use the AOAC methods unless a different method is specified in Code of Federal Regulation. 21 Code of Federal Regulation, section 101.9C, talks about the different regulations for nutrition labeling pertaining to the method. Now, in terms of FSIS for meat, poultry, and egg products, so they follow USDA Analytical Chemistry Laboratory Guidebook that has different methods specific for meat and poultry and egg products. Or if they don't have the particular method from there, they would specify an AOAC method. Now, these are two important compliances, and then there are another set of compliances. We call it level of compliance. And this is pertaining to the declaration of the amount we have on the nutrition label. Now, not lying this time, I want you to remember these numbers. There are not a lot, there are 3 numbers to remember here. If the product, you have added vitamin C, for example, or you have added iron, or calcium, or even protein, or dietary fiber, or potassium. So you added something that was not originally in your ingredients as inherent component. Since it's added, if the agency, federal agency comes and randomly analyze your product and finds less than 100% of what you claim, then you're not in compliance. You have to have at least 100%. So companies, for example, orange juice, we used to give this lab, now we removed it due to addition of another lab. I used to bring in orange juices that are processed in different ways, fresh, refrigerated, and frozen. And sometimes we see that the vitamin C was like 120% of what they claim on the label. Why do you think they do that for vitamin C in particular? Yes, Madura? Absolutely. Vitamin C is susceptible not only to processing, degradation, thermal processing, but also over storage. It gets oxidized and then got lost. So they want to make sure they have enough vitamin C that lasts the entire storage or shelf life that they put on the bottom. Naturally occurring. So they are in your sample, in your food product, in the ingredient that you've used. it's okay if they are 80, 85, 95% of what you actually have in there. So you have a leeway of 80% or higher. But there are certain components that we don't like to have higher than what we see on the label. These are the calories, the sugar, the total fat, saturated fat, cholesterol, sodium. That these are the components that in excess might not be desirable. So here, although they are inherent, they tell you, okay, above 80, but not more than 120% of what you put on the label. You cannot have calories of 150 and you're claiming 100 calories. So that is out of compliance. Okay, you can ask questions if you have any clarification question. There are now nutrient claims. So with nutrients claim, you would say high source of, or a good source of, or an excellent source of, or it's calorie free, or fat free, or low in sodium, or lean in fat, light, reduced, less. There's so many different words that you can put as a claim, but each of these have a specific definition as to when you can use them. So this table 3.7 from your edition 4 of the textbook, you currently have edition 5. And for some reason in edition 5, they removed this table, and I talked to the editor, we're bringing it back in edition 6. Because I feel that's a good resource to have. And for you in particular, you have a lab report, and one of the questions is going to ask you what claims can you make, or what nutrients claim can you make? Is it high in calcium? Is it excellent source in calcium? Is it low in fat? So you really need a reference. I don't expect you to memorize this, of course, but you need it as a reference. You need that in front of you if you want to answer that question. So for calories, for example, in order for you to say free, it has to have less than 5 calories per reference amount per serving. A reference meaning if you have a full fat yogurt, that's your reference. Fat-free yogurt. So you are comparing your fat-free yogurt to your full fat regular yogurt. Low. So 40 calories or less per reference amount. Reduced at least 25% fewer calories per reference amount. So basically, again, if it is reduced fat milk, for example, it should have 25% less fat than your whole fat milk. And then the other nutrients goes on for total fat. You will have the same for saturated fat, for cholesterol, for sodium, and then also for sugars. But you also have another table in the edition 4, which you can probably find online, for other types of nutrients claimed that are the good nutrients, like say calcium, iron, that we want to see more of, basically. Health claims. So the FDA approved so many different health claims over the years. And the way the FDA approves claims is based on medical studies. So you have many years of research and monitoring of the impact of consuming calcium in sufficient amount and osteoporosis. Usually osteoporosis is common in older women because of they lose calcium probably for childbirth and other reasons. So they found over the years of medical research that consuming calcium at a specific amount can prevent osteoporosis. So you can see products like orange juice sometimes are fortified with calcium. So they put calcium and osteoporosis on some of these products. Dietary fat and cancer, fruit fruits and vegetable enhancers, especially to the presence of dietary fiber, sodium and hypertension, folate, and neural tube defects, sugar alcohols, and dental caries. So these are just few. There are many others, like 25 grams of soy protein a day prevents heart diseases. It got contested for a little bit, and then it was not removed. That's one example. It wasn't removed as a claim. So this is the lab, and I needed to show this last Friday for the Monday lab, and I didn't. But for Wednesday lab, this is what you're going to do. You're going to generate nutrition label for yogurt formula. You're going to change the formulation and see how that impacts the nutrition labeling. You're going to add an ingredient to enhance the calcium content and see how that impacts calcium reference date intake. You're going to observe reverse engineering. You're going to make a nutrition label for chocolate chip cookie. And then you need to review chapter 3 or this lecture. And then chapter 5 is your lab manual. I hope you've got your lab manual. And if you don't, Kat is bringing physical copies of chapter 5. If you need that in the lab, make sure you watch the video in media gallery. Complete your pre-lab quiz. Also on campus by 9 a.m. Bring your lab notebook with you. We're going to be taking notes. And we're going to meet in room 2020. Oh, 22. 220. Okay, so I still have 10 minutes. Why not? I'm going to start a new topic. Or do you want to go? You don't want to go?
Well, we have to stay here and
Yeah.
What do you want?
We stay in the same seats and then go to the next class.
Oh, so we can continue. All right, I like that. I don't know if your friends like that. Okay. Where's my mouse? There we go. Evaluation of analytical data. So in every lab, except nutrition labeling lab, starting next week, you will be getting a set of data and you're going to do simple statistics on that. So you're going to determine the mean, you're going to determine standard deviation, you're going to determine coefficient of variation, and you're going to determine percent relative error, and confidence interval in some cases. And sometimes you need to do a Q test. Now, what is a Q test? This is a test that tells you if one of your replication is off, it's skewing your precision and it's skewing your accuracy. So you do a Q test and then you look at this replication and say, I can reject it based on the Q test. I remove it from my set of replication and then my precision will be better, my accuracy will be better. So this is just utilizing simple stats to evaluate how precise your values are, how accurate is your measurement, as well as where your confidence interval is. Let's see here. Method A is more precise in measuring glucose content than method B. If method A has lower standard deviation, if method A has higher standard deviation, if the mean obtained using method A is closer to the true mean. A and C, B and C. Just a sec. Go ahead, Taylor.
A.
A. And any other takers? Do you agree with Taylor. Yes, I do too. So yes, so standard deviation has to do with precision. Coefficient of variation is based on the standard deviation and the size of the mean, so it also has to do with precision. C has to do with accuracy. Okay, so A is the answer. All right, so how do we determine or evaluate our replications, basically, or replicate analysis for accuracy and precision? So first of all, we measure central tendency. So in all of our labs, we will be measuring the mean. Median usually is used for large set of data. It might be important in sensory analysis, for example, but in our laboratories, and then the number of replications we do always range between 3 to 6. So median doesn't make much sense to us, but the mean does. So in every experiment, we will be determining the average. We'll be running it in replications and determining the mean or the average. Now, we want to determine whether or not our analysis is reliable. First of all, it's important to assess accuracy, how accurate, how close to the true value or reference value. And then also we want to assess our precision. How precise are we? Are our replications close to each other, or are they really scattered? And sometimes it's not the method's fault, it's just the person that's doing the assay needs a little bit more practice to be more consistent and to be able to produce accurate results. Then we look at the errors. The errors, is it systematic error, something you can't control? The balance is not calibrated. You're always measuring using the balance, but it's giving you the wrong amount or mass, and that's causing a systematic error. Or you're using a mechanical pipette that is not calibrated. So that it's not your fault. You know how to use the pipette, but it's giving you 0.9 ml every time instead of giving you 1 ml. That's a systematic error. Another error is you don't know how to use a mechanical pipette. So that's causing always error in precision and potentially large error for accuracy. Specificity, how specific is your method? We talked about it a little bit last 2 lectures ago. So are we measuring total carbohydrates in general? Are we measuring glucose? How specific is your method, basically, to what you are trying to measure? Now, what is sensitivity versus detection? Anybody can tell what sensitivity means? When we say this assay is very sensitive, what does it mean to you? Yeah,
How fast you can detect a certain aspect, like
fast? You said how fast?
Yeah.
Doesn't really have to do with how fast. It has to do with, yes, Priyanshi? Yes. So how small of a change can be detected? So if you have 2 samples that are different from each other, but in very small amount or very small measurement, how sensitive is your method in detecting that difference? So the smaller difference that can be detected, the more sensitive is your method. Okay, what about detection limit? Or threshold? Means the same thing. Threshold, detection limit. What does that mean? Yes, Ash?
That's the minimum size of change that your method can measure.
So minimum change, difference or change, that's sensitivity. This is the minimum amount that can be measured. So that's the lowest concentration that can be measured, for example. If we're looking at concentration, and almost all labs, we're looking at concentration. So what's the lowest concentration that can be detected by your spectrophotometer or by your HPLC? So the lowest concentration. Okay, very good. Curve fitting. a lot of the time, we're going to have a regression line. You're going to calibrate. So you'll be calibrating in the HPLC lab. You're going to measure caffeine in different beverages. So you need a caffeine standard. So what you will be doing is preparing caffeine at different concentration, and you're going to get the area under the curve using the HPLC, and you're going to plot the Y, which is area under the curve. The x-axis is the concentration, and you're going to get a calibration curve, which has an equation of the line and an R value. So you will have most often linear regression. In our lab, mostly we will have linear regression. So you will have the equation of the line y equal ax plus b. A is the slope, b is the intercept, y is the dependent variable, x is the independent variable. So you will determine how well the data fits the straight line. You're going to determine the strength of your prediction. So the higher the R squared, the better is your prediction of the line. So when you have 0.999, that means you're very, very certain that your concentration is predicted as close as possible to whatever you calibrate. Okay, so I'm gonna stop here 30 seconds prior to the end, and I'm gonna ask some of the Wednesday lab folks to shift to Monday. We're very slim on Mondays, and I need at least 10 people on Monday, and I have 7 people on Monday. Do we have 3 gracious volunteers? And next Monday we'll bring bagels for breakfast. Bribery, bribery, bribery. If you want to think about it, those of you on Monday, you're all gonna get it anyway, the bagels. So this is really good for, think about it on Wednesday lab. We really want to make sure that we don't have a group of 6. We don't want to have many people in one group, so I want to distribute. So please think about it and email me. I need 3 gracious volunteers. Yes.
I was gonna ask you about the switching for Wednesday lab.